In epistemology, in philosophy, we also say that the map is not the territory. It's another way to say that what you're describing with your scientific models, with your words, is not the thing in itself. When you speak about something, you're making a simplification so that you can better understand it, better predict, or better relate to it.
Clément, thank you so much for joining me.
Thank you, Baham. It's a pleasure.
Today, we're discussing your new paper of meaningful mass of the universe, cosmology through the lens of complexity and evolutionary sciences. I thought the title itself was very interesting. You introduced the concept of a mask to talk about models of the universe. And just to frame this a little bit, we always had this model of the universe before modern science, that the universe was created for man by God, so we could fulfill our duty. So there was that sense of meaning already through religious scripture, the way it was described. Modern science replaced that, modern physics replaced that, and gave us a model that had no inherent meaning in it. It was all parts and forces. So we're now trying to see if there's maybe a third option here. So I want to hear from you and how you see the issue.
So what you said is very much correct. And actually, one way Paul Davies frames it is to say that science has been able to explain a lot of things that were attributed to gods, a storm, lightning, or now we can explain this. And with the theory of evolution, we can even explain why there are different species that look so well adapted to their environment and so on. So actually, the problem of apparent design in the world has been gradually shifted towards the very beginning of the universe, and because we have also general models of the Big Bang and the formations of stars, galaxies, planets. So if we kind of stitch together all the models of the different sciences, we can reconstruct a big story of the universe. But the very beginning is still problematic because you need to start with something. And typically the scientific view on how things unfold is that you start with initial conditions and fundamental laws, and you plug these initial conditions in the laws, and then you can predict what will happen next. So that's really the paradigm of Newtonian science, of the science that Newton developed. But yes, it proves insufficient in many respects, but we'll get to that. I wanted also to clarify that so this idea of masks, it comes from a cosmologist named Edward Harrison, who wrote a book called Masks of the Universe. He says in this book that if we look at the history of ideas, we've had different ideas of what a cosmogony, what the origin of the universe was, what the universe is all about. And yeah, nearly all of them have been refuted. We can really be sure that even our scientific models are the truth. And he says, well, maybe not. So maybe it's just another mask. And so that's why what I'm trying to argue in this paper is that the mask of mainstream physics and cosmology is largely insufficient, both scientifically to explain especially the phenomenon of complexification and evolution, and also insufficient to provide any meaning, any inspirational understanding of what it means to be human on planet Earth in the cosmos.
I love the analogy because a mask gives something a structure, so it models, but at the same time it hides the truth, right? So it has this sort of double.
Yes, and what I like also is that it's okay to change masks. You can drop your mask and take another one, and yeah, you see things differently, and you can do this several times. In epistemology, in philosophy, we also say that the map is not the territory. It's another way to say that what you're describing with your scientific models, with your words, is not the thing in itself. When you speak about something, you're making a simplification so that you can better understand it, better predict, or better relate to it. But the reality is always more complex than you think.
So should we discuss the current mask we're in right now? What is the current mask? You go through sort of modern physics, thermodynamics, all these features of this current mask that we're in. And I think beautifully describe why it's such meaningless mask that we're in, and it could cause a lot of anxiety. So do you mind elaborating on this current mask?
So the first big mask of that started the scientific revolution is called the Clockwork universe. So it's a mechanistic analogy that the world works like a mechanism, with the idea of having initial conditions and universal laws and forces. And if you have these two things, you can predict the future of what will happen perfectly. And actually, this paradigm of science, of Newtonian science, was extremely problematic for a lot of philosophers of the 18th century. For example, Immanuel Kant, much of his work has been trying to find a way to reconcile the hard science. He knew that Newtonian science was very serious, was very powerful, with the more intuitive human ideas of free will and the fact that the world doesn't seem like it's determined in advance in all its parameters. So that's the first problem with this clockwork view, is that if you take it seriously, then there is no free will. Everything is determined from the start. And yeah, you think you have free will, but no, it's just it was there in the initial conditions, and that's how things will unfold. And the reason it works is that that it apparently works, it's that in the equations of Newton, the time doesn't matter. Time is reversible, so you can go back in time to explain things, or repredict things, and you can go in the future to predict future situations. And we often think of Einstein and relativity to be a great revolution, which it is in many respects, but actually not with respect to determinism, because the equations of Einstein are also time reversible. It doesn't matter where you put the time parameters, you can put it backwards or forward. So yes, it doesn't improve the situation. Now, after that, there was a revolution of quantum mechanics, who shook the foundations of this clockwork universe and found out that randomness and uncertainty is foundational to apparently the ultimate constituent of matter. And so this brings actually a kind of totally opposite twist to the story. So instead of everything being totally determined, then suddenly it's actually reality at the bottom is totally random. So if you take seriously these two theory, or at least naively, then you end up having the choice of believing that we live in a universe where everything is determined, or in a universe where everything is random at the bottom. And both are very unsettling, actually. And then what you were saying about thermodynamics, because this is like the third major theory in physics. You have relativity theory, quantum mechanics, and thermodynamics. And if you apply thermodynamics to the universe, then the famous second law of thermodynamics says that energy gradients will tend to dissipate, and the universe will end up having no stars anymore and end up in a heat death. And if you have no energy, then you have no life or complexity that is possible to sustain anymore. But yes, the thermodynamic part is important because it introduces a direction of time. So it complexifies the picture.
So we talked about time, and I know you mentioned also process. as sort of segue into a new mask, that instead of seeing structures driven by forces, we need to focus on dynamics, complexity. What's this bridge now that we could take and talk about the universe as a process rather than parts and forces?
Yeah, so this comes down really to metaphysics, this idea of how should we describe the world, and classical science focuses on objects and interactions. Some philosophers, it starts with the pre-Socratics. They said that the process, the change, is the only thing that is stable. Heraclitus said, you never swim 2 times in the same river, because there is a flow and constantly changing, actually. So you can choose in your ontology to focus not on the objects, but on the processes that are around it, and then an object, like, even, for example, if you think of a mountain, you can think of it as a clear object. But if you think over geological timescales, then it's magma that burst off the Earth's core, and that created this mountain, and they are still moving, actually, and growing. So they are not objects; they are processes. They are things that are changing. So yes, in this view, objects are just processes that are stable enough so that you can kind of draw a boundary around them. We, as agents, as cognitive agents, can put a boundary, but yeah, it's somehow arbitrary. It's somehow for convenience that we do that. And also, there is this famous saying that, it's not a saying, but yeah, I'm not 100% sure if it's correct, but the idea that after 7 years, because you are humans, we are a living system, very open to new oxygen, new food. After 7 years, almost all your cells in your body have been replaced. Maybe just not your neurons. So are you still the same person if everything has been replaced?
So there is some sort of process that's holding whatever we are together, regardless of the material or the structure. And of course, evolution is a process, right? It's natural that then you talk about evolution. And perhaps the best introduction to talking about evolution in the cosmic scale is Lee Smolin's work of cosmological natural selection, where you later offer an extension of that, where humans may be playing a role there. But should we start just talking about Lee Smolin's idea of cosmological evolution and how that ties into this new mask?
Yes. So actually, Liz Smolin was very aware of and concerned by this problem of the fine-tuning of the initial parameters of cosmological models and the standard model of particle physics. And so what physicists have noticed is that if you change a tiny bit some initial parameters, such as, for example, the expansion rate of the universe, if it was a bit higher, then the universe would have expanded very, very quickly, and there would not have been time to form galaxies and stars, etc. And on the other hand, if it was a tiny bit slower, then it would have expanded and then immediately collapsed again. So it seems that this parameter is fine-tuned in a range that allows for complexity to emerge. And it's a long discussion, but many explanations to explain this fine-tuning problem are insufficient. And the big insight of Liz Smollin was to be inspired by evolutionary theory. And what he does, he makes the analogy of evolutionary theory of the notion of species before Darwin. So the idea was that God created the different species as fixed things, and yes, it seemed incredible that they were so well adapted to their environment. So that's why you had to appeal to a designer. And but yeah, then Darwin comes and has a theory of evolution that can explain this dynamics that leads to this situation. And he says the situation with cosmology is actually analogous, that you have these parameters that seem to be fit to make a complex universe. And so instead of thinking that the laws of physics are fixed, you can, like in biology, think that the species were not fixed and have had an evolution. So he developed this theory called cosmological natural selection, where there are a population of universes. A universe can, through black hole, can make a new universe appear with slightly different physical constants. And so through generations of multiple universes, they would get better and better at making new universes. And so, for example, he predicted that if we would change the parameters, we should get less black holes, because this would be something that would have been optimized for an evolutionary universe. And the biggest drawback of this theory is that in evolution, you need a mechanism of heredity. And here there is no clear mechanism of heredity. How does the information pass on from one universe to the offspring universe? It's not really specified.
A theory that rivals that is multiverse, where there are infinite number of universes, and this one just happened to work. And the fact that we're here to ask this question is because this would only happen in the universes where the parameters worked out. And this, I'm sure, ties to the anthropic principle. But that to me is also dodging a process. Do you also see it that way?
Well, the problem with this, I mean, there are several problems. First, it's ontologically extremely extravagant. It means that you really assume that there are billions and trillions of universes with all possible combinations of parameters. And then you explain, although it's not really an explanation in the strong sense, our situation with a selection effect. So the selection effect concept is very important in these discussions about the entropic principles and the multiverse. But basically, so just to illustrate what a selection effect is, if you imagine you go fishing and you take a net with squares big like this, you throw it, and then what you fish are fishes that are at least maybe big like this or even bigger. And can you conclude that there are no fishes smaller than that? No, it's because the way you looked at things, when you fished, you selected only actually the bigger fishes. But the problem with that is that it's not explanatory. You don't have an explanation of why there are these fishes there. So it's part of an explanatory model to be aware of the selection effects. And astronomers, they are especially good at that because there are tons of selection effects happening for all kinds of reasons. So my point here is that the traditional multiverse theories are really insufficient and ontologically extravagant to try to explain why our universe and not another one.
The idea that there is a process seems much more feasible to me, at least, than the sort of extravagant theory, which there's no proof or evidence for it yet. And of course, talking about evolution then on a cosmological scale makes you think whether then something like life on Earth could be maybe playing a role in the universe's fecundity in some way, or maybe those initial parameters were set in a way that inevitably would get life on a planet and maybe advanced civilizations. So you talked about as sort of an extension on Lee Smol's idea, and of course your work on extraterrestrial search and the work you're doing for looking for signatures of intelligence in the universe, I'm sure ties to that. So do you mind speaking on that a little bit, how you see that tying back into the cosmological evolution?
The main drawback of Liz Molin's cosmological natural selection is that you don't have an hereditary mechanism. And some authors, including me, have proposed to complement, to remedy this situation by arguing that it's actually intelligent life that would steer the making of a new universe. That would let so if you imagine the very, very far future of human civilization or post-human civilization or whatever we may become, or actually the phenomenon of science. So science is about modeling the world, or if you want a computational analogy of trying to compress what we can observe and make a model, a compressed description of it. And so in my view, even the enterprise of science is not just purely descriptive. It's not just for our pleasure to understand the world. It's a mechanism that is in the universe so that intelligent life can build a model of the whole universe and at the same time other possible universes, that intelligent life can understand the constraints of and the possibilities of other universes to maybe one day make a new universe and make this universe fecund to complexity, to life, and so that the life cycle can continue. Another universe can produce also intelligent life, and which would in turn also produce a new universe. And why do all that? Because of the threat of death, of the heat death of the universe. That there is a finite amount of energy in the universe. The energy is going to be degraded. I mean, some people are fine saying that, okay, we're just here for a while and we'll die and everything will die off. I mean, I can't accept that personally. And there is also a quote by Charles Darwin where he says that it's an unacceptable thought to think that all of the biological complexification would be doomed to annihilation. So yes, what living things want to do is survive and reproduce. So that would be the ultimate game of intelligent life in the universe, is to make a new universe so that life at a cosmic scale can continue.
That's very interesting, and especially with humans, because we have this power of self-reflection. Maybe by realizing this fact, then we could manifest it. That's what I picked up on your tone when we were talking about something like advanced civilization's role. The fact that we could realize this now maybe makes it more likely to make it happen.
Yes, exactly. So that's a very interesting twist indeed. That again, it's then doing science and understanding the world is not anymore a detached enterprise, like I'm just going to study this and see. No, suddenly humans are embedded in the process and have, if this whole picture is correct, then we have almost a cosmic responsibility to pass on the torch of life and intelligence. And maybe other civilizations have been doing that or are doing that as we speak.
And what I mean, that's such a major shift. It goes from you're just a random coincidence and it's all going towards death to you have a responsibility to make the universe fit. I mean, it's so profound. So I always thought this sort of endorsed view within the science now, where it's all randomness. We happen to be here by chance, and the fact that we're here is very cool. We could enjoy this sort of grand structure of the universe, and that's where the meaning lies. But I always thought that that seemed a little forced to me. I mean, the way like even Neil deGrasse Tyson talks about it, even though It's scientific and it's trying to make people be in awe of scientific discoveries and the process of the universe. To me, I always felt that putting a meaning there was secondary. How science talks about meaning now is very different than this new mask.
I would say that there can be some inspiration, but it's at a very emotional level and superficial level. So look at these black holes, like a star, amazing, these two neutron stars merging, and we can detect the gravitational waves that they are making. So yeah, it's very impressive, but it doesn't connect with our deep biological past, and it doesn't provide any vision of what intelligent life and complexity could do in the future. It doesn't address the heat death problem. And I'm not sure if it's the case of Neil deGrasse Tyson, but indeed a common response to the death of the universe. Instead of falling into despair, so that's one possibility, you can accept this and then just be an Epicurean, to enjoy life. You have this little gift of life, and then you try to enjoy it. But then if you do that, you don't have a vision for the deep future. If you're rich, you might give a legacy to your children and grandchildren. But even then, what does it mean? Yeah, I feel it's still very shallow.
So you also talked about teleology, and what's interesting, it also ties into evolution. To me, evolution seems like a vehicle for teleology and final causality. And it would be natural to also then wonder whether there's some teleological system going on at the scale of the universe, but still in a naturalistic way. You mind delving into what you meant by that?
Yeah, so it's a delicate issue, it's a delicate question. So in 2006, I founded the Devo Universe community. And the goal was to create a network of researchers who want to explore how far the dynamics of our universe are evolutionary, so just random chance, adaptation, contingency, etc., versus developmental. So that means that actually the change are highly constrained and directional, much in the same way as an embryo. So the embryo starts with one fertilized egg and then differentiates in a very actually predictable manner, at least on a big scale. Like most embryos, human embryos will end up having two arms, two hands, two feet. So these features are very predictable. But on the other hand, if you look at a smaller scale, like even in identical twins, they have unique fingerprints. They don't have the same fingerprints. So it means that there are also contingent random noise dynamics that are not specified in the DNA. And we are still exploring. And if you're watching this, you're welcome to apply to join the Evo Universe community. We want to understand in how far the dynamics of the universe is evolutionary or developmental, or you could say, yes, in a way, teleological, or that at least that there are some attractors in the dynamics of the universe. And another way to frame this is to paraphrase the question that Stephen Jay Gould asked. He asked about biological evolution, what would remain the same if we would replay the tape of evolution? So imagine, go back in time 5 billion years ago, and you hit play again. What kind of biosphere would you end up? Do you get bipedal mammals like us, or would you get intelligent dinosaurs, or would you get, I don't know, super intelligent dolphin-like creatures, or something totally different yet? And there is no consensus amongst experts. It's not a trivial question at all. And what I did in a paper is I asked the same question at the level of the universe. So what would remain the same if you would replay the tape of the universe? Then yes, most cosmologists would probably agree that you would get galaxies, stars, maybe planets, but would you get also life? Would you get mammals? Would you get intelligent life? It seems that as you get more and more specific, would you get Parham? Would you get this conversation? Then it seems like, no, there is a limit to that. So yes, I think that's a very important question to ask about the universe and how far it is evolutionary or developmental. Now, more generally, the problem of teleology is that it is at odds with Newtonian science, as we said, of having the initial conditions, the laws, and from this you have a mechanical prediction of what will happen. Teleology or attractors in dynamics work in a totally different way. So even if you take the simplest biological artifact like a thermostat, you set the temperature. So you're kind of setting the future state, and the system is able, through a sensor effector loop, to sense the temperature. And if it's too cold, it heats up. And if it's too hot, it cools down. And with this, it's capable to keep a temperature stable. So is this mysterious? Of course not. It's just an interaction. But the interesting thing is that you have a feedback loop. You have a sensing capacity of the temperatures, and the goal, you have a goal that is set to a certain temperature, and then a comparison of what is sensed with the goal. And then an effector, the capacity to act in the room to activate the heater or to activate the air conditioner. So this kind of feedback loop dynamics, the Newtonian reductionistic science is totally blind to them. So that's why you need more other sciences, actually, complex systems, cybernetics, that incorporate at heart these dynamics, which are the most interesting, actually.
I recently read a paper by Adam Frank where he talks about planetary intelligence, and he mentions that the better search for intelligence actually would be planetary, like advanced civilizations, not the sort of bacterial search that we usually think about when we think about life on other planets. How do you see planetary intelligence? What's the role of planetary intelligence in this cosmological process? We talked about sort of humans maybe having a role. Do you see the sort of more planetary scale intelligence playing a role there?
Yeah. So as you know, I've been working and inspired by the concept of the noosphere. It's a concept that was introduced by Pierre Teilhard de Chardin and Vladimir Vernadsky. It's simply said, it's a third stage of the development of planet Earth. So the first one is the geosphere. So it means everything about the non-living Earth, rocks, water, air. And then life emerges on Earth and eventually populates the whole Earth. And then you have the emergence of a biosphere. And what Teilhard and Vernadsky foresaw 100 years ago, actually, is that humans and their technology are actually developing a third layer of planet Earth, which they call the noosphere. So the word comes from the Greek nous, which means thought or reason. So a sphere of thought that is enveloping the Earth. And this was, yes, well before the internet. This was just at the very beginning of information communication devices. I think clearly we are in a phase, what I would say it's a major evolutionary transition at a planetary scale. We are kind of creating a planetary superorganism. So something that is more capable, more intelligent, more connected than just its parts. And so the infrastructure are all the material infrastructures are all the communication channels that we have, the internet, but also satellites, mobile phones, everything that allows rapid communication across the globe. We have also the distribution of matter and energy. We have energetic grids that can transport energy. We have at least in the Western world, we have almost all the products we want in the supermarkets, thanks to the global trades and global routes that can bring all kinds of products everywhere. So matter, energy, and information are distributed globally. And this is just the basics. And now you need more than just pure information. The information you can refine what kind of information needs to happen. Well, the vision actually of Tim Berners-Lee, who invented the web, was to allow computers to develop like a brain. So he wanted people to be able to associate any piece of text with an image, with a video. So to make any pre-association like the brain can do. And so, so this enabled the web and I mean, it seems so obvious and so natural to us, but it was not at the time. And I think it's really a major breakthrough, both on the idea and on the technological side, to have to use such simple and robust protocols as HTTP and TCP/IP to enable this. But now we are way past this, and there are many new layers of information, and also, most importantly, that everything that happens on the internet is more and more tightly connected with the real world, which was not the case in the 1990s. If you speak to someone who was on the web in the 1990s, he will tell you, oh, it was a much better place with a free spirit and so on and so on. So now it's highly politicized. Nation states or any kind of actor can know how to manipulate the information flows for their own agendas and so on. So it becomes actually urgent to develop new levels of intelligence, of regulation, immunity at these levels, because they are having direct impact on everything. And so, yes, I think that's our major challenge for the next decades to come, to build a kind of consistent, well-working noosphere, infosphere, and regulating what can happen and what should be banned and what is dangerous, especially also with the rise of artificial intelligent agents that are going to populate the internet massively the next year.
The idea of a major evolutionary transition, which has happened in biology and usually results in more adaptation, more survivability. So hasn't happened a lot, but whenever it happens, it has led to, due to the fact that as a collective, system survives better. So I wonder if something like that is needed for the vast amount of processes, especially information processes, to help us just make sense of it all in a collective way.
Yes, an insight I had when I was writing a paper about, which is called "What is the Noosphere?" So title is "What is the Noosphere? Planetary Superorganism, Major Evolutionary Transition and Emergence." Is that, so if you look at this hierarchy of major evolutionary transitions, the highest scale systems that are really self-consistent are actually the nation states. They are the most powerful global high-scale actors. And in this view, the major evolutionary transition has mostly to do about the integration or regulation or harmonization of the different nation states, because problems at the geosphere level, so climate change, pollution, and so on, they are often triggered by nation states. And they don't care because the pollution goes everywhere, or climate change affects everybody. So there is no higher control mechanism. There is no global governance that can stop them or reduce them. So they act as free riders, as selfish actors at the level of the planet. And what a major evolutionary transition does is it creates a new level of control that can regulate the different parts so that they don't screw up the whole system. So we need that for the planet to avoid dramatic climate change, to avoid nuclear wars, etc., all the existential threats.
That makes sense. And some people might say, and I disagree with this view perhaps, but some people might say, if you're saying that the noosphere, the sort of collective organism at the planetary scale, if it's one of those attractors of the universe, it's a pattern in the universe that was likely to happen, and this major evolutionary transition that we're going through is a natural course of the universe, why should we take any action to tackle climate change? Why doesn't it justify inaction? And I'd love to hear your thoughts, but the way I think about it is people are usually driven more by hopefulness and moving towards a goal than fear. I feel like when there's fear, it's has less of a power to mobilize people.
Yeah, my thinking is that a positive hatching of the noosphere is not inevitable at all. We know that biological evolution is extremely wasteful. Something like 99.9% of all the species that have existed have disappeared. So evolution is incredibly wasteful. So if we transpose these statistics to all the planets in the galaxy, maybe there are 99.9% of the noosphere that fail. It could be. And we might be in a road that makes the noosphere fail. Or, I mean, I believe it's up to us to take action and to take responsibility. And I believe it's possible, but I don't believe at all in destiny. So like the worldview you outline is based on this idea that there is some kind of external force in the universe that will make everything right. But yeah, I think it's a very dangerous point of view that is conducive to inaction, to carelessness. Just a few, maybe, let's say, to be conservative, 1 century ago, it was completely unthinkable to think that we should care about the planet as a whole. But nowadays, there are many who are thinking about things like geoengineering, so modifying the planet, or thinking about, how to manage pollution, how to manage the waste in orbit, or I mean, all kinds of things that are truly global in nature. So we have the power to act. So that's my point, that the people who are fatalists, often they do that because they don't have the power to act. And then regarding your question about fear and hope, yes, actually, I think both can work to mobilize for action. But yeah, so of course, fear will tend to trigger more gut reaction, more primitive reactions to survive, or reactions that are not well thought on. Whereas hope is more constructive, positive, and can lead to more thinking about how to create solutions that are win-win for all parties that are involved in a particular situation.
It makes me wonder, some you talk about this new mass, and I have a feeling that none of this theory is being taught at schools, like to middle schoolers, high schoolers. There's this bias in education, which is the second mask, modern physics bias in education. I wonder if, even if this was just briefly discussed in elementary school or middle school or high school, wherever it would be appropriate, I think it could have a drastic shift in kid perspective on how to live even.
Yes, 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 and you're absolutely right. And I mean, our colleague and CEO at Human Energy, Sheila Hassel-Hughes, has been teaching ideas about the noosphere, and she has reported really transformative feedback. So, okay, so we are part of this. We can actually act, and it's a very hopeful narrative and empowering narrative. And yes, and it seems also that also the overflow of information over the internet, the issues of internet addiction and so on, they also are actually paralyzing generations of people who can just scroll down an infinite scroll and just worry about the next thing. So yeah, we live in a very toxic infosphere, and yes, and all these systems are very, very addictive. So it's actually very hard to cut them off, but it's necessary if we want to take action and fix the world. And yeah,
You have a quote in there I really liked. Human beings are not anymore isolated entities in an indifferent universe, but integral parts of an immense cosmic history with an immense future cosmic potential for the continued evolution of life and intelligence. And to me, that if if to me, so it has such an ethical and almost spiritual effect that comes from a naturalistic. And there was no magic, what we just talked about, but yet it has this effect.
yes, yeah. So I think it's also one reason why Teilhard de Chardin was so inspirational is that he was a paleontologist as a training. He was both a scientist and a priest, a Jesuit priest. And so the fact that he looked at geological or paleontological timescales made him this created a kind of springboard to also think about the very far future. So he could envision things about the deep future, and I think it's the same with if we stretch this to cosmic evolution. If we are becoming aware that we are part of a cosmic history that lasted 14 billion years, then yes, we want to continue the story, not just 100 years in the future, but thousands of years, millions of years, or even maybe billions of years. And I think we should be inspired by this, and not be tied to our human timescales. It's the 100 years kind of timescale is the natural timescale for humans, but there's nothing special about it. And life could have started much before than when it started on Earth. And actually, there are arguments based on astrophysics on the age of sun-like stars, that on average, sun-like stars, they are about 2 billion years older than our sun. So it means that with the most conservative assumption that if life emerges next to a sun-like star in the galaxy, then on average, other civilizations, they are about 2 billion years or senior.
2 billion years ahead of us. Is that what you're saying?
2 billion years ahead. So you see what we've been able to do in like 200 years. Now I try to imagine what they could do in 2 billion years.
Already built another black hole. They're living inside of it.
Possibly, yeah.
Fascinating. I think it was Julian Gall. He was telling me something very interesting before the James Webb Telescope created those pictures. He made a prediction that there would be really large black holes, very massive black holes in early universe in a way that wasn't predicted. Have you heard of that theory?
Yes, sure. So it's tightly linked with cosmological natural selection of Lee Smolin. And so basically the idea is that the early universe, because there were a lot of replication cycles before, they would have had to, if you take cosmological natural selection seriously, they would have to be able to have black holes very early on so that they can make new universes rapidly. And so that's why he made this prediction that we should see black holes in the very early universe, and he was dead right. So that's a very interesting prediction, and he has other predictions about the structure of the universe and the filaments and the voids that we see of the large structure of the universe that would be due to the jets of black hole that were at the early universe. And the interesting thing is that these jets ejected in a helicoidal fashion. And this should be testable actually with observational cosmology to test whether these filaments have this kind of structure. So we should be able to test the theory further soon.
One other section you talk about fractal mathematics and propose that might be better mathematics to talk about cosmic processes. Do you mind talking about that a little bit? Why fractal is important here?
Yeah, so if you take the history of relativity theory, Einstein, when he was trying to develop general relativity, he was struggling to find the right mathematical tools to address his questions. And then he asked advice to mathematicians, I think it was Hilbert. And he told him, yes, of course, we have this non-Euclidean geometry that can help you with your equations. And so it worked perfectly to describe the space-time structure that he was busy with. The tool of the mathematical tools could help to and was essential actually to build the theory of general relativity. And what a French researcher named Laurent Notal proposed is that actually you can make a further generalization of geometry, of non-Euclidean geometry, by also including non-differentiable functions, so functions that don't have a tangent. And the thing is that if you have a continuous space-time that is non-differentiable, then there's a theorem that says that space-time should be fractal. Mm-hmm. And yes, so the interesting thing is that more or less at our scales or in our situation, the space-time is kind of Euclidean. It's standard. We don't see weird things. But at the very small scales, the space-time becomes, you have a kind of phase transition where space-time becomes fractal. And that's why actually we have all these weird quantum behaviors. So it's it becomes a geometric interpretation of quantum mechanics that says that that quantum phenomena are manifestations of a fractal spacetime. And it's very beautiful because the postulates of quantum mechanics, the axioms of quantum mechanics, can be derived from this more general framework. And there are also fractal effects at larger scales, which might explain big problems in cosmology, such as dark matter or dark energy, more dark energy than dark matter, actually. So yes, it's an extremely promising theory that has already validated predictions in many areas. And it's founded really on something solid, which are relativity principles, whereas quantum mechanics was discovered by experimentation and the axioms were laid out, but the axioms came from experimentation, not from a deep theoretical understanding. So yes, I'm very enthusiastic about this scale relativity theory. And stay tuned because I've interviewed Laurent Notal a few years ago, and I will be publishing videos of this interview where he speaks about all that.
Great. And where can people find out more about that interview and your work more in general?
So the website for EvoDevo is evodevouniverse.com. And the book that I would recommend to start with the theory of Laurent Notal is called The Relativity of All Things Beyond Spacetime. The Relativity of All Things Beyond Spacetime. And it's a good introduction. And then there are many papers and two other technical books that goes into the technical details of the theory.
Great. Well, I look forward to that interview. So maybe one last question is, where do you think this new mass, this new model of the universe should go? It's an open-ended question, but I'm specifically thinking in terms of research priorities, testing capacities, of ways to test this, or in terms of education. What do you think is next? Because as profound as it is, it probably takes also a lot of effort to disseminate it and also scientifically build on top of it. So where do you see this going?
Yeah, so I guess what I would like to see is scientists that are trained more in an interdisciplinary fashion, so that, and especially with concepts from systems theory, cybernetics, which is really a language which has been developed as a language to be able to describe different sciences. And so to avoid reductionistic assumptions and models. And yes, and so that other more cutting edge ideas can be explored also seriously, although they can be daunting to explore, like things like cosmological natural selection. It's very speculative. It's hard to tackle, but I don't think it's impossible. So yeah, it's to try to bridge more gaps between the speculative hypotheses and their testing with the people who really observe and build specific models. So I think these gaps need to be explored and filled. And yes, for education, it's the same. We live in nowadays in a very complex and highly accelerating world, and we need our kids to learn other thinking tools than just very simplified models, even mathematical ones. They are generally oversimplifications and have limited uses, strong assumptions. And so to have a more general framework to think about complexity, about evolution, I think these are keys for understanding the future and pushing the science.
Well, thank you so much for this great discussion. I wanted to ask, where can people learn more about your work?
Yeah, so you can check my website, clemvidal.com, CLEM vidal.com, and also the website of Human Energy, humanenergy.io, to learn more about the Noosphere and giving meaning to our present time. And so, as I mentioned, evodevouniverse.com. So this could already be a lot. And yeah, this is my book you mentioned at the beginning and the end, The Meaning of Life in a Cosmological Perspective. So you can either buy it or there is a preprint also available on archive. Well, most of the ideas are.
Great. Well, thank you so much, Clement. I really enjoyed this conversation. I think we covered a lot, and I hope we can have more fruitful discussions like this in the future.
Great. Thank you so much, Farham.